So we should be live now. All right. Thank you everybody for dialing in and for coming to our meetup tonight. So this is the 28th PyData Cambridge meetup. And as has been the case for more than a year now, we're holding this one online and as well as the ones in the foreseeable future. Nevertheless, we hope we have an interesting event for you tonight. So we have two talks. I have a couple of slides, and for the meetup regulars, this will probably not be, there will not be too much surprising in there. And then we have a talk by Vincent Warmerdam, who's going to talk about optimal benchmarks and other failures. A short break to allow for some questions and maybe to get up and stretch your legs. And then another talk by Alexander Senf, who's going to talk to us about Global Alliance for Genomics and Health. And just as a word of warning, so the meetup is recorded. If you're not comfortable with that, feel free to leave. The recording will be published after the event, shortly after on YouTube on our on the PyData channel, and the link to that is at the end of the slides. So a little bit of a recap, who are we? So we organize the PyData Cambridge meetup. We've been going strong since November 2018 now, and we've managed to hold monthly meetups every last Wednesday of the month in the Raspberry Pi building when there was an in-person meetup, and now online. And the four organizers are, except myself, is Federico, Leandro, and Ole. And we're all volunteers, so we like Python, we like data, and we like doing data science and things like that. So this is a volunteer effort. We organize things, as you know, under the umbrella of the NumFOCUS organization, who sponsors us through PyData, as well as sponsoring many other open source projects. And we're very grateful for their ongoing support. So yeah, once again, NumFOCUS is our umbrella organization and our main sponsor. So a couple of the NumFOCUS projects that if you donate your money goes towards, that you can help supporting. Pretty much any well-known package in the ecosystem for scientific data processing is there, going from NumPy, Jupyter, Julia, and so on. So if you like the meetup, if you like data science with these packages, please consider donating, and you find the link at the bottom of the screen. So we do have a code of conduct. We ask that you behave professionally and courteously towards the other participants, and just treat other people like you want to be treated yourself. If you find that you don't feel particularly comfortable in the meetup and you think you've been treated in a way that violates the code of conduct, you can let us know. Or if you prefer to take it up with a third party, you can contact Leonie Muck, whose email address is also given at the bottom of the slides. And then last, before we dive in, quick thanks to our sponsors. So our sponsors keep making the meetup possible. And we currently have the following four sponsors. They all get a chance to basically tell us a little bit about what's going on and what they can do. And this may be also worth pointing out that for the time being, even though we're not handing out free pizza and beer, sponsorship is still very important because there's fees to pay for Zoom, for Meetup, and so on. There's a little bit of overhead, and they help us cover that. If you apply for any of the jobs that they have listed on the next two slides, or if you contact them because of something that came up in the meetup, please mention that PyData Cambridge is the reason why you found out, and then they can see that their sponsorship is money is well spent. So a couple of updates from our sponsors. ARM is looking for a number of people to join various teams, and the job titles for open positions are listed here, as well as a short description. You can find more information on the ARM careers page, which is also listed on the bottom of the slide, or you can talk to or contact Federico or Leandro, who are in this meetup. And then Raspberry Pi, who, when we were still holding the meetup in person, kindly hosted us in their fantastic building. They have made the switch to online, and they're hosting weekly live streams with educational activities. So if you're interested, do join in. The link is listed on the slide, rpf.io/home. And you can interact with people and talk about cool projects involving Raspberry Pi. And then our sponsor Fetch.ai has a number of updates that they would like to share with us. So they've released an alpha version of their collective learning framework on the GitHub repository that they have. And they have codes that you can use or that you can experiment with or collaborate on that they would very much like you to test you out. So there's an email address if you want to, if you find something that is of interest and you want to collaborate, that you can contact Fetch.ai on. And they also have a Discord for ongoing discussions and talks. They also have a couple of job opportunities for DevOps engineer, software engineer, for basically wide-ranging stack of technologies, and machine learning scientists and engineers. And you can find out more on fetch.ai/jobs. Sorry. Okay, and I think that's it. Didn't skip any slides. So to wrap it up, we are always looking for speakers in COVID times, more so than in the normal times, because it's harder to go out and network with people. So if you know anybody who can be a speaker for the meetup, or if you want to volunteer a talk, do get in touch. Even if you're not certain that the talk will be appropriate, we love to discuss and love to help you out. So the barrier is really low. We're also looking for sponsors. As mentioned before, the sponsorship fee makes a lot of things possible. So that's very welcome. As I mentioned, the recording of the meetup will be made available on the PyData YouTube channel, and you can find the link on the slides. If you want to give us a shout out over Twitter or say how much you enjoyed the meetup, please do so and tag us in it, as well as the speakers. And if there's anything that you want to discuss or bring up, you also have our email address. So with that, I will stop sharing, and I will invite our first speaker, Vincent, to share his screen. Maybe just before I give the introduction, I do want to say, and I think most people have already done that, if you want to introduce yourself in the chat box, in the meantime, feel free to do so, and virtually high five each other. That's great. So our first speaker for tonight is Vincent Warmerdam. He is a research advocate at RASA in the Netherlands, where he collaborates with the research team to explain and understand conversational systems better. He's been evangelizing data and open source for the last 7 years, among others as one of the organizers and actually co-founders of the PyData Amsterdam chapter. And he's here to tell us, as the title indicates, about optimal benchmarks and other failures. Thank you very much, Vincent, for joining us, and the floor is yours.
Sweet. So just a few things to check. My audio is good. That's the...
Yeah, can hear you loud and clear.
Cool. And like you can see me like do the doodle here. Hopefully that's also working. Okay, great. That's everything we need for the audio video segment. Hi, everyone. My name is Vincent. I work at RASA, and I would like to talk to you today about benchmarks. In short, what I do at Rasa is I'm a research advocate. So that means that half my time is spent in doing stuff in the research team, and the other half of the time is spent doing stuff more on the developer advocacy team. Another way to sort of point that out is to say, well, I'm kind of the interface with the research team and let's say like developers in our community. One thing that I'm especially keen on supporting, it's kind of like a task that I've picked up myself within the organization, is to make sure that we have plenty of non-English tools in our natural language processing stack. And it's this non-English thing that I will also shed a little bit of light on today. But I'm basically a person who tries to do both of these two things. And that means that part of what I do is I have a YouTube channel where I explain all of our algorithms. That's a pretty big part of what I do. But the role is also kind of natural to me because outside of, Rasa, I'm also involved with a whole bunch of open source projects. I maintain quite a few of them. And in particular, what I would like to talk to you about today is why I felt the need that I should add another one to the whole stack. But what I'll be talking about first and foremost is just how I like to run benchmarks. And in particular, I would like to just highlight this little tool called Memo that might be very useful. So from this point on, everything that I'll be doing now is just code. These were all the slides that I intended to show. So I'm about to show you the results of a benchmark, but before I go there, I would just like to talk about how a lot of us do benchmarks, because we kind of have to talk about this for loop that we're all writing all over the place every single day. And like what I'm hoping is that there's some sort of recognition that you have, let's say, a for loop that calculates something, and then you start out with an empty list. And then what's happening here is you have this for loop, and the for loop has like the grid, like all the different settings. And then you have a function that calculates something, but you're always appending something to the list. And then you have your like data set, the thing that you're interested in. We all write this for loop daily. And the thing is, like, what I've got here is like a very silly simulation experiment. It's not necessarily super fancy. It's the birthday experiment. Like the number of people in your class, what's the probability that two people share the same birthday, that kind of simulation. But even a simple function like this gets annoying really quickly, because what I'm doing now is I have the class size as a function input, as well as the number of simulations. But now if I want to maybe also tweak the number of simulations, so then I have to do like for a sim in like, I don't know, some number of simulations here. And then I got to do this indentation thing, and then I got to do this number of simulations thing. And, if I now do this appending this way, I still have a list with data. But now I got to worry about how do I link the size parameter with the correct measurement here, and how do I link this sim parameter with the correct measurement here? And very quickly, this for loop just becomes a mess. And I don't know about you, but I've been here before. Like at some point, I just noticed this pattern. Like, Vincent, you got to stop doing this. This is just silly. You just got to abstract this away. Okay, so here's what I figured I would do. How's about this? I'm just going to say, well, let's say that there's an output here. I'll call that proba. And the output is always a dictionary. Let's just do that. And let's just say that I've got my data list here somewhere. And then the only thing I might need is from this library called Memo. Maybe I need to have a decorator called memList. And what I'll just go ahead and do is I'll add a decorator to this one function that calculates a whole bunch of things. And then, yeah, I need to pass it this data. Like so. And then the idea is every single time that I run this function, it's just going to log all of the inputs as well as this output together, and it's just automatically going to append that to this list. And then I'm done. Like I don't have to worry about any of the for loops, just all the logging is taken care of. So that means if I now just manually run this birthday experiment with a class size of 10, the number of similar, just run this a couple of times for a few settings. Let's just do this. If I now look at my data list, you'll see that it's actually populated, which is nice. But now if I turn this into keyword arguments, let's do sim here, then everything gets logged in one fell swoop. And what's nice about a list of dictionaries is if I now import pandas, this list of dictionaries can always be turned into a data frame. So that's pretty sweet. And another thing that's nice is even if I don't want to have a data frame, this just totally allows for, if I have like another output foo bar is equal to 42, like I can have multiple outputs. That's not a bother anymore. But the main thing that I like is I'm no longer fiddling around with some sort of for loop. Now, this is just the idea called memo. Like I just needed some sort of a way to like deal with all this data. But what's nice about the library is I also allow you to like have a couple of other fancy decorators. So for example, why do I log to just a list? What I can also do is I can log to a file path. So I can just say, look, this is my results.json file. I would like to have everything logged there. And what I can also do is I can have this helper method that can generate this grid for me with all the settings that I want to loop over. I could turn it into a list real quick, but basically these are all the different settings that I'm interested in. And then what's pretty fancy is I can also have like this little bar that tells me the status. And again, like I have my data set here and it's just nice. Like this is a nice way to do grids if I think about it. So also, this is everything that Memo does. The only thing that Memo does is it gives you like a couple of fancy ways to like handle your logging and some helpers. Right now, I'm just sending it to files and lists, but there's also a setting where you can send it to like a backend, like a web server. So you just want to log to like some sort of centralized logging thing. That's also possible. But this is the idea behind this tool called Memo. And so far, you might think, well, this is pretty neat, but I could also use grid search for this inside of scikit-learn, right? If I'm doing scikit-learn stuff, then the grid search should handle this, and then the grid search should also parallelize and do all of those things. And you'd be kind of right, but let me talk about this one exception to that. So as part of what I do at Rasa, I try to make sure that we have plenty of support for non-English languages and that people feel free to play around with them. I also do a little bit of education there. So one of the projects that I maintain on behalf of Rasa is this project called What Lies. And the whole idea behind this project is that you can figure out what lies in word embeddings or language models. And these are the kinds of models where you have some sort of text and then you give that to some sort of language model. And what comes out for that text is just this one little vector. That's what word embeddings are. That's what language models are. And the only thing that What Lies does, well, there's a bunch of things, but the main thing that it does is it gives the same interface to translate a text to numeric vector. So if you're using byte pair embeddings, it's an interface, but even if you're using Hugging Face, it's the same interface. This project makes sure that all these different backends just give you the same result. And what's really cool about it is that I was able to design it in such a way that this byte pair language is like one of the language backends. It's one that has support for 275 languages, by the way. But what's nice is you can just add that into a scikit-learn pipeline, and then this becomes a featureizer as well. So then you just say, okay, I want to have the Hugging Face thing with logistic regression, and you can still just use scikit-learn. No need to learn the Hugging Face thing. And this just works. So it's great. But this language backend, I mean, it depends on how it's been implemented, but you cannot assume that you can pickle it. Like it might be written in C or C++ or something fancy. It's probably not something that's completely written in Python. And if you cannot pickle it, then you cannot serialize it. And that also means that grid search will no longer work. The big caveat with grid search inside of scikit-learn is that everything needs to be serializable. And you cannot guarantee that for very fancy machine learning pipelines like these language pipelines. So the reason why I started working on Memo was I was just tired of the for loops, like it drove me nuts. But the other reason is also that there are these moments like this one where grid search is just not entirely what you're interested in. And what I'm going to do now is I'm going to zoom in on a benchmark that I was running. It's like the thing in particular that I'll be talking about for the rest of this talk. But I hope that people look at Memo and sort of go like, oh yeah, it's kind of neat. And I hope that people also understand like, hey, there's merit to having like these language backends. And go to the What Lies website. I support over 275 languages with this thing. If anyone has questions about it, feel free to reach out to me on Twitter as well. I'd love to hear feedback. But the idea is I have this task, this classification task, and I'll just show you the benchmark that I'm running high over, and then we'll see how Memo fits into all of this. But The idea is I have some sort of a data set. It's just a classification task. And then I would like to pass in a string that represents a model. There's also some sort of embedding I would like to use. There's a train size, there's a test size. And basically, this is a function where all the logic is happening in. But the main thing that's important is that I have this function over here that generates the model on my behalf. And this generate model generates the thing that I will then call .fit on, which later I will do some predictions with. And then at the end, I'll return like the accuracy, the stuff that you're typically interested in. But the main thing that's important is I have a function where strings are able to go in, and all the logic that needs to happen for the benchmark is happening on the inside here. And in particular, I have this really sort of silly function over here that can generate the model where it's just a bunch of dictionaries and a couple of like these cached scikit-learn pipelines. I'm using the universal sentence encoder here. I'm using fast text embeddings over here. And I've got this setting here where I'm just using count vectors to sort of encode my text. But what's nice about Memo, again, is I'm like super flexible in how I do this. Like I'm not constrained by how the grid search likes to have things before I can make a grid. I can just define everything with functions. And at the very bottom, what I just do is I have this giant grid and I have all sorts of settings that I'm looping over. So I've got fast text and universal sentence encoder, etc. Now, I'm doing something in this benchmark that most papers don't do, but it is something that I highly recommend. I'm doing two things that are kind of interesting. For starters, I'm comparing fast text and universal sentence encoder, which are two fancy sort of embedding techniques. But I'm comparing that basically against the simplest thing you can do, which is just count vectors. Just encode every word as 1 or a 0 and give a giant array of sparse things to a logistic regression. Most papers that I read on text classification and like state-of-the-art benchmarks don't do this. But we'll keep it in mind. Another thing that I'm doing is I'm also saying, well, I do my proper train test split, but I'm also kind of interested in just the effect of the train size. Like maybe certain embeddings work better if you don't have a lot of data, and other types of embeddings work better if you have a lot of data. There's something to be said for that. And usually if you have a proper benchmark in a paper, they just assume a big train set and a big test set. But they don't do this extra little step that says, hey, let's just check if the size of the training set even matters. Okay, so, this is, I have the script. It's on my server. The server's going brr, and then at some point I have my results. Now, there's a couple of ways of doing your results, but I'll just show you some tricks that I like. What I've got here is basically I'm opening up my my log files like I showed before. This is just on disk, but I'm opening up in pandas. And after that, I'm giving that to a tool called HiPlot. And HiPlot is a really, really likable tool. If you haven't seen it before, the idea is that I have parallel coordinates here. And for all the different parameters, I can do queries. So one thing I can do is I can say, well, give me, I don't know, the examples where the prediction time was super high. And then, okay, and you can kind of see that it's because I'm using this one sort of embedding over here. Okay, well, that's interesting. But what's even cooler is I can say, well, let's select a portion of the train size, and let's see how all the other metrics change as I increase the train size. And you can be like really fancy and say, oh no, let's make like a subselection on multiple axes. Like that's the cool thing about this visualization. You can very quickly make these cuts. But in the interest of time, the main thing I would like to draw your attention to is you'll notice that there's like a lot of high accuracy tests here, but I would like to keep your eye on this axis. So I'm going to increase the training size, but then let's see what happens to the accuracy in my train set when I do that. So I'm first selecting train sizes that are low. We see that the accuracy over here, they're all like super high in the train set. But as I move this up, notice that the accuracy in the train set actually kind of goes down. Now, obviously, this is all within like 1%, so we shouldn't really claim too many things here anyway. But the fact that you have this interaction makes this a really cool tool to play with. And that's something I just found really interesting. So I just really quickly wanted to show you this, because if you haven't seen this tool before, like HiPlot is really, really sweet. It's just really good for this sort of thing. It's nice and fast. But in this particular case, I figured, this all of this stuff is interesting. But if I select like the best performing things here, I very quickly come to the conclusion that maybe it's not really the embedding that's doing the work. It's maybe just the train size, if I'm honest. Okay, so if that's the case, then I should make a plot with the train size on the x-axis and sort of see what happens. And I like it when things are like, interactive. So I'm using Altair for the charting here. And what I'm showing you here is the results from the fast text embeddings and the universal sentence encoder. And I don't know about you, but let's zoom in on this. Right? Let's zoom in here in the beginning. So there's like maybe a percentage difference, right, in the beginning. Maybe. And same here at the end, like maybe percentage difference. But to now start yelling like, hey, my universal sentence encoder, that's state of the art. I mean, that'd be kind of a failure. You'd be dismissing the fact that a lot of the things that you're doing here depend on the size of your training set. Like that's the thing that's causing the uplift. Compared to the size of the training set, like this is small beans. And when I'm at it, I mean, what I can also do now is I can say, well, I'm only comparing fast text to the universal sentence encoder now. Should I maybe, rerun this whole thing, but also with the n-grams, like the basic count vector trick? Can I just take that? And when I do that, I mean, now we're really going to have to zoom in now. But now, when you zoom in, you really, really got to zoom in like a lot to even spot a difference between fast text and these count vectors. Like you really, really got to zoom in. This is like a order of magnitude to the power of -5, like difference in performance here, right? So okay, I'm doing the benchmarks, I think, in a cool way. I'm using Memo, I'm using all sorts of fancy tricks here, and all that stuff is nice. But if I were to now sort of look at this, and if I were to ask myself the question, like, is this a meaningful benchmark? Am I doing something clever here? Then I hope you would agree that, the main thing that I should be doing is I should maybe estimate, the velocity that I still have here, and maybe see if I can propagate that forward and maybe do some more labeling. But I really shouldn't be bragging too much about these embeddings. Like that's not really the thing that's driving this forward. And I want to mention this explicitly because I am really disappointed at all of these research papers that say, oh yeah, we have a data set that's like 2,000 labels and 50 classes, and universal sentence encoder works best. I mean, that's great, but your velocity is still super big here. Like you should focus on training data. You shouldn't focus on these machine learning models. It's not the most effective thing you could do. But it even gets worse. I've only shown you some quick tools now, but what I haven't done is I haven't talked to you about what I'm even doing. Like I've not talked about the data set at all yet. But the data set that I have here, it's not a bad data set, but it's a intent data set. The idea here is I have lots of, let's just show you like a few examples, I guess, that makes it clear usually. But it's a data set kind of like, hey, I've got a sentence here. How would you say fly in Italian? And if this is a text you would give to an assistant, the assistant should say, oh, like your intent is you want to translate. Like that's the class that I should associate with this sentence. Like that's the task that I'm sort of benchmarking here. And, if I then have a look at all of these labels, and if I then say, well, let's do a value count on that, and let's then also turn it into a dictionary, then I can sort of see how many examples I have for all these different intents. Okay, sure, I've got like 150 examples per intent. That's not bad. But I mean, there's an intent for paying the bill. There's an intent for bad spelling, for setting an alarm, for whisper mode, to confirm reservations, to check your flight status. This doesn't represent an actual virtual assistant. This is like 150 different intents. This is like all of them almost, like all the standard ones that you might find in maybe 20 chatbots. But this doesn't represent a single virtual assistant. And when you think about it this way, it becomes even more silly to sort of hyper optimize for one of these data sets. And the main lesson here, of course, is like reality is way more complex than a CSV file ever will be. And we really got to be careful that we're not fooling ourselves when we're doing these benchmarks, right? Because it's not just on sort of the practical level of the, hey, reality is complex, but also just, grid search is just so easy to fool you and sort of you're chasing the wrong rabbit. And with that in mind, I started thinking about this new open source package that maybe I should start writing. If we're talking about what rabbit you got to chase, maybe we should take a step back. Because if nothing else, what I've learned from this benchmark is that maybe these sparse tools, they just work fine for a lot of situations, maybe not very complex ones, but there's a lot of situations where, taking your text and passing it through a sparse array and just giving that to a machine learning model will just do the trick. It might just get you to 90% accuracy. Then you got a lot of interpretability. So maybe we should just figure out ways to make this better. So I started wondering about that. Like, what can you do here? Well, one thing that we can do is we can maybe start thinking about this partial fit phenomenon. So in scikit-learn, not every model has this, but there are these models that don't just do fit predict, but there are also models that do a partial fit. The idea there is that you're able to say, well, let's split my data set up into chunks, and let's first train the model on this portion, then on this portion, and then on this one, with the whole idea that you don't need to have the entire data set in memory at all times. You can just train on like micro batches and sort of stream through an entire file and then be done with it. But the standard scikit-learn pipeline doesn't really allow for that. Standard scikit-learn is fit predict. And even if we have transformers that allow for this partial fit, we kind of needed a new pipeline for this. So I made this tool, and the tool is called TokenWiser. And it's just some scikit-learn compatible tools that allow you to sort of play around with tokens in a bit more of a flexible way. And the first feature that we provide is we have a partial pipeline. It's a pipeline that allows for this partial fit, which means that you can train on these separate batches instead of one single batch. And scikit-learn then has a hashing vectorizer and an SGD classifier that you can put in, and they will just work out of the box, and you can train these models like on a streaming more setting, so to say. It's not really streaming, but it's close to it. The other thing that we also do, let's just start running some cells. The other thing that we can also do is we can then start thinking like, hey, do we have like transformers we can put in here that sort of make it easier for us to find interesting patterns in text? Now, one thing that people typically like to talk about is like, hey, let's do the n-gram trick, where we're going to take every single subword and encode that into a huge sparse array. And if we do that, we're robust against spelling errors, because even if we don't hit on like one of these subwords, we might still hit on all the other ones. That's fine, but like you might have this super huge sparse array. So instead, what you might want to do is say, like, let's just take text and let's just split the text up due to like hyphenation. So it's astrology, like that's the way you would pronounce a word. And maybe if we can take like a normal word like this one and then transform it into this, well, then the hash vectorizer would know these are the 3 subwords to just go ahead and vectorize. No need to like have these huge sparse arrays anymore. And when you have a sentence like megaton dinosaur head, it becomes megaton dinosaur head. And there's things to be liked about here. Another thing that you can do is you can use the Yake trick. Yake is a library that does text summarization. It tries to find portions in text that are the most important. So if you are dealing with long news articles, this can be a way to like summarize that in a small form. Yake is a pretty cool tool for that. But what's even nicer is that we also have like feature union tools. So you can make very complex pipelines where first we clean the data, like we remove all weird spelling, weird characters, and then we keep the string as is, and then combine that with the hyphenated text. I mean, you can build pipelines whatever way you like them. And there's some extra tools I would just like to mention here. Let's just show them real quick due to time, because I am almost over. Like some other things that I think were pretty neat to have here as well. We have phonetic preparation tools. So what we encode is not the text, but rather what it sounds like. So we have these data banks that tell you what a word sounds like in English. So we can also encode to that. Might also be robust against certain spelling errors. We can also use a tool like Spacey to say what part of speech a word is. This way, the word duck as a verb is different than the word duck as a noun, which is also useful information to encode. If we're using Spacey, we can also lematize the text. So that means that we get the infinitive of a verb instead of the entire verb. So it can also reduce your vocabulary. There's lots of these tricks that I just want to have in a library. And as of today, you can pip install TokenWiser, and these can be already some tools you could go ahead and play with. So I have 3 minutes left, and that brings me to this other thing that this library also does. This is the Steve Jobs, there's one more thing moment. So this partial fit, right? That's kind of an uncommon way of doing things inside of scikit-learn. But if you think about it, a lot of machine learning tools actually do work this way. Like most neural networks, they train on these batches, and that's sort of the way that they expect things to run. There is this other very popular open source package out there called Spacey. And I started wondering, which pipeline do I like most whenever I'm doing simple benchmarks? Do I like scikit-learn more? Do I like Spacey more? And especially with Spacey 3, I'm kind of inclined to say, well, I don't think scikit-learn is for everything anymore. I think there's some stuff I just want to do in Spacey nowadays. But man, I would really like it if I could use my old tricks. The thing is, because Spacey does deep learning things, the only way Spacey will train is by using this partial fit mechanic. So you cannot do standard scikit-learn pipelines inside of Spacey. You just can't. Unless you use TokenWiser. Because one of the things that we can do inside of TokenWiser is we can say, well, let's just follow the new standard Spacey setting registry. That's a new feature. Don't have enough time to go into there. But in short, what we do allow you to do now, using this library, is we allow you to say, well, here's a partial pipeline. It has to be a partial pipeline. You have to have the partial fit thing in here. And what you can then do is you can say, well, let's just link that. And from here, you should be able to just run the standard Spacey train loop, but you can have scikit-learn inside of Spacey and use scikit-learn as a benchmark. And that's the badass thing. Spacey has some lovely models. Some of them are somewhat heavyweight, but it's nice to do this super simple thing with just this bag of tricks to just have the benchmark there so that you know the base rate, so you also know that you might not need something that's super complex. And that's what I'm trying to do with this library. I'm trying to just have, the slogan for the project is TokenWiser. It's a bag of tricks, not words. But the goal of this project is to just have a sort of a place to celebrate the fact that we can keep things simple. Maybe we just need a couple of these tricks instead. And the main thing that I'm really trying to prevent here is this. I want to prevent these kinds of failures where we are really fooling ourselves that we're doing state of the art, while instead we're just solving the wrong problem. So TokenWiser, What Lies, Memo, these are all things that I'm working on. Some of these tools I'm building on behalf of Raza. Some of these tools I'm building on behalf of myself. But I hope that this has given people food for thought. And here's the fancy logo I designed for this project. I hope people find this interesting. I have a little roadmap of things I would like to do. One of the things I will also do is I will add support for Vopal Wabbit, which is also this really cool tool. Works via sort of the same training procedure I mentioned before, also a streaming trick. But this is what one of the hobby projects that I'm currently working on. And I'm hoping this is useful to other people.
Great. Thank you very much.
30 seconds left. I almost had it. Almost had it.
Right on the dot.
Almost had it. But now would be a great time for questions. I have a Q&A sort of chat thing open, but I didn't see any questions pop in. Don't know if that's a separate. Oh, wait, chat. Now I see. There you go.
I don't see any questions yet. We'll give people a bit of time to collect their thoughts. But in the meantime, I wanted to ask a quick question. So I want to latch on to the last thing that you said, that TokenWiser is a bag of tricks. do you have an interface if I have a trick of my own that I want to add to TokenWiser? Like, is there a base class to implement or a specific API?
The only thing I do is I integrate with scikit-learn, I integrate with Spacey. That's it. So as long as your trick is scikit-learn compatible, I think we're good.
Okay.
And like you have to convince me that it's a trick that I'm willing to support. Like if you have a fancy like BERT model, then this is not going to be the package for it.
Right.
What lies is going to be the package for that.
Okay.
And there's some extra stuff I didn't have time to discuss, but the main idea is like Spacey, scikit-learn tricks, and an exchange between that. Like that's what I'm trying to do here.
Yeah.
And also, like, just because you're Cambridge, I just to all the ARM and Raspberry Pi people, you rock. Like this is fun toys, man. I just wanted to like, don't know if there are any employees in the room, but just wanted to say like that's really cool stuff.
I think there's probably a fair bit.
I would assume so, but yeah, if there's no more questions, then there's no more questions, I guess.
I have actually another question, if you don't mind.
Yeah, go ahead.
To go back to the beginning of your presentation, you showed the grid generator.
This one.
Yeah, exactly. Do you have any thoughts about supporting generating bags of parameters that are not regularly spaced, where maybe you even take into account how your experiment behaves? Oh, great.
So there's a random grid. I've added it because I knew that this question would come in a presentation sometime, which is happening now. Having said that, I never really use it. And again, that's because I experience these grid search differently. I'm really not going for state of the art. Instead, what I'm doing here is I'm probing. I'm trying to understand the underlying system a bit better. That's my primary goal. I'm not doing like the Bayesian optimization thing typically. And I might also argue that, yes, I have found a use case with machine learning for this memo library. But one of the features is also that you can do a grid thing and then log to a server. So it's not really tied to machine. It's not meant to be super tied to machine learning. And if I recall correctly, I think rich is like the only dependency I have on this project because of this fancy progress bar. But nothing is stopping you from like doing a grid, looking at the data frame, defining a new grid, and doing that loop yourself. But the hyperopt is not the goal here. It's just making things a whole log simpler. That's what I'm trying to do here.
Thank you. In the meantime, I think we have 2 more questions in the Q&A box.
I'll answer the last one. What motivates you to start these projects, and are they used externally or just inside Rasa? My other question, what languages does Rasa work on? Okay, so the first question is, I do know that they're actually used. So there's this website called, we can check actually, epy.tech. So if I type what lies in here, then you see the download numbers. So what lies has a couple hundred downloads a week. This is not like massive or anything, but I do know it's being used. Memo is like fairly recent. We have like 100 downloads a week, which is not nothing, but it's also not like, I mainly wrote it for myself. I just don't mind open sourcing it. So the thing that motivates me is just I have an itch. I want to scratch it. What lies came to be because I had an itch that was work related. And then my boss said, oh yeah, let's open source that. That's something we can share and other people are going to find it useful. Now, as far as like the languages that Rasa works on, we typically try to be language agnostic. Like anything that we don't, the main thing I try to do is if there's a tokenizer missing for a specific language, and I figure out a way to maybe add that to Rasa. Like that's some of the stuff that I do on a day-to-day basis. Like you just have to notify me that something's missing and I'll try to figure it out. All the tools that Rasa makes in general, like we integrate with Spacey quite directly. So you could say, yeah, that's a lot of European languages, but in general, we try to support everything. It's hard, but we don't have a language preference. Someone else said I had a use case to use scikit-learn's nearest neighbor retrieval benchmark against Annoy. Will be used token-wise over string wave doing that say tree for retrieval since both Annoy work well. I mean, I've benchmarked Annoy against scikit-learn's nearest neighbor. Annoy just typically wins. Will I be able to use Tokenwiser to have a streaming way of doing that using scikit-learn's KD tree? I don't know if scikit-learn's KD tree has a streaming setting. I think it just has fits, not partial fit. Feel free to ask me that question in more detail on Twitter. I think I'm not 100% sure, Ajita, what you mean with the question, but feel free to reach out to me and I'll check it out in more detail. And if people are interested, by the way, like if people want to like play around with another tool with another itch that I scratched, just for fun, Google human learn. Just Google it. And to give you like the shortest preview, one of the things that it features is you can like actually draw a machine learning model, which is then also scikit-learn compatible. Just saying, if you haven't used it yet, this tool's pretty sweet. Also, itch. I wanted to scratch. Also, someone said state of the art, and I just drew a model instead. I think that's it for questions, right?
Yeah, thank you very much. That was really great.
My pleasure.
If there's any other questions for Vincent that come up while we have our second talk, feel free to post them as well. Vincent, if you are able to stay with us a little bit longer and there are questions, feel free to answer them. But if not, people can reach out to you on Twitter and keep the discussion going.
Yes. Add me on Twitter and I'll stop sharing the screen.
Thanks. So with that, it's time for our second speaker of the evening. We have Alexander Senf up next. So Alexander, we didn't try sharing your slides, but if you could try sharing your screen, and we can see if that works.
Host disabled, participant screen sharing.
Then I need to do more black magic. All right, can you try again?
Yes.
Awesome. Thanks. While you get set up, let me introduce our next speaker of the evening. So our speaker is Alexander Senf, and Alexander is a principal bioinformatics software engineer at Congenica here in Cambridge. And he's also the task chair for the Crypt4GH encrypted file format standard. And prior to joining Congenica, Alexander and I were actually colleagues at NTOT for a while. And he's here to tell us about GA4GH, which is the Global Alliance for Genomics and Health. Take it away, Alexander.
Thank you. Yeah, so today my goal is really to introduce the GA4GH as an organization, what it does, and if you're working in the bioinformatics space, maybe you've come across it, maybe not, but I just want to hopefully gather some interest here and help you to explore what we are doing in here. So even now working at the Genomics Health company, I noticed that the GA4GH is not really a well-known organization, even though if you work in the space, you probably have used standards that have been either designed or supported by the GA4GH. So where did it all start really? I want to start out simply by saying that what it stands for is the Global Alliance for Genomics and Health. So it's an organization that tries to promote human health through the use of genomics. And in its founding documents, they refer back to the UN Charter of Human Rights, which contains a clause that says that every human has the right to benefit from scientific progress. I think about 167-ish countries have ratified that in 1976. So technically, this would be a legally actionable right that every human has in most countries on Earth. And to benefit in terms of your health from genomic research falls under that. So that's one of the preambles of the GA4GH. And it tries to achieve that primarily by enabling the sharing of genomic data. So going back to really the mid-1990s here when we started having like the Sanger method of getting genome data. What a lot of people noticed is that a lot of labs started to create genomic data. They stored it. It was new at the time, so every lab independently created their own formats. They siloed their data. They didn't share it, which it's understandable for a new field. But the people, especially if you reach the mid-1990s and we see the start of the Human Genome Project, if you try to project forwards, you can already see that the genomic data would have a huge impact, or it was at least believed it would have a huge impact on understanding human health and also developing therapies and so on. So even back as far as the 1990s, there were people already concerned about the ecosystem that would allow us to share this data. And that includes data formats, that includes the policy that allows sharing data, that includes the willingness of people to share data and so on. You've seen incidents of that during the Human Genome Project. So for example, once Craig Venter, for example, joined, he wanted to keep all the data private and charge money for access to it, whereas the Open Consortium people were adamant that everything had to be publicly available to support science and encourage progress. So this kind of, this discussion has been going on for a long time. Eventually, in 2013, this led to the formation of the GA4GH, and a lot of the people who were involved in it for the past 20, 30 years were part of this. So that really goes back in its origins a long way. I'm having a lot of links in this presentation. Please feel free to contact me if you want them, so you don't really have to write them down. But the main goal of the GA4GH is to develop open standards, sharing, for example, if I sequence the data, that you can read it with the tools you prefer to use. But that goes beyond the technical standards. It also goes into policy. So for example, if I do sequence a human genome, would I even be allowed to share it outside my borders? Under what conditions can you use data? What kind of information can I include? If I have phenotype, what is there publicly identifiable information and not? So these kind of policy questions the GA4GH also tries to address. As an organization, it is actually fairly small. So there's a small dedicated staff, and nearly everyone within the organization actually has a main job and does GA4GH work as part of that main job. The dedicated organization mostly supports planning, planning of conferences, support providing Zoom meeting rooms, etc. But by and large, the idea is to have it embedded not only in research work, but throughout projects that happen in industry, in academia, in national initiatives, and so on. And in addition to that, we reach out to volunteers and really anyone who is interested. So in order to participate in what the GA4GH is doing, you do not have to be a member of the GA4GH. You don't have to work for a member for the GA4GH. It really is open, and anyone is encouraged to participate and contribute, both to the development of standards as well as to the development of codes, etc. But the goal really is to do something that is useful in this space. So it's not a standardization organization that creates standards that may or may not be useful, but then they're done with it. On the contrary, a standard will only be developed or supported if it actually has a real use case, and if it is actually actively being used by the community and if there's interest in it. If you want to see an overview of all the different kinds of standards they have, there's various links. Most of them start with ga4gh.org, so that is a great website to get more information if you're interested about the individual bits. I'll talk about the individual components in a little bit. So the way it is organized is you have, from the GA4GH organization on the left-hand side, Each standard is grouped within a work stream. So we have the discovery work stream, which deals with how do I find the data I'm interested in, which is not easy, especially if you're dealing with 30, 40 different databases you might want to search. But it's especially hard if you're dealing with access controlled databases. So if you're looking for a specific allele for some genomic research you're doing, how on earth would you find that allele? Currently, you have to read papers, and then these papers link to data sets, and you can go to these data sets in archives. But there is an effort to make this a bit more discoverable so that you have tools that would allow you to get an idea, oh, it's in this data set, and then you may apply for access to that data set without, with the data still remaining safe. We have large-scale genomics, which deals with how do we handle the data we're working with. This is primarily file formats, BAM, SAM, CRAM, etc. And also the cryptographic file format crypt4gh, which I'm working in. The data used in research ID, this is more of it's a combined policy and a technical issue. This deals with if you are a researcher, how do we know you are a researcher? What kind of ID would tell me that you are a bona fide researcher, in other words? And data use tries to come up with an automated system of classifying how you want to use data. And both of those together, hopefully, will enable access decisions towards access control databases on a more automated basis. Because currently, if you want access to an access control database, you apply to an data access committee. They review your application, say yes or no, and it's a manual process, so it doesn't scale very well. There's a cloud work stream. More and more of what we're doing happens in the cloud. So in order to make that useful, easy to use, scalable, it's an important aspect. And even more important than that, if I run an analysis on my laptop, if I run it in the cloud, if I run it in a different cloud, I always want to get the same results back so that the workflow that I have is scalable. And here the idea is eventually the data sets become too large. So you want to be able to take your workflow, put it next to the data, run it there, get back the results rather than downloading the data and running it locally. But it has to always produce the same results. Genomic knowledge standards, things like variant interpretation. If you find a new variant within a gene, what does it mean and how do you actually write down and share that knowledge in a way that others can understand it? And then finally, clinical and phenotypic data capture. This is an interesting bit because G4GH started as a research organization, clearly with a view towards going into the clinical space as well. And that is actually quite a huge gap that has to bridge here. And clinical has evolved in a different way than research, but we still have to be able to share data between those domains and make sure we understand what each other mean. Ontologies, the terminology, interpretation data, things like that. And in addition to that, there's a regulatory and ethics and a data security work stream. Those simply are there to ensure that the standards that are being developed and promoted and supported follow certain minimum requirements. On the top side, we have real-world projects. So here, it is important that whatever we develop is being used. Again, we do not want to create standards that are then sitting on a shelf somewhere. So every participant works on an actual research project, on an actual academic project, on an actual industrial project, and contributes that work to the G4GH. And that way, the standards that are being developed are already being used at that point. So it is something that has real-world application, that has real-world code and support, and so on. If I go closer towards Cambridge, if I look at who's involved in the local area here, so we have Genomics England, which is a contributor as well as a user of standards. They're using standards like HTS-GET, which allows you to access genomic data via API, but just the regions that you need. So you don't have to download everything. We have the Wellcome Sanger Institute, which participates to a lot of the work streams, and many of the maintainers of the file formats are at the Sanger. Then the European Bioinformatics Institute, EBI. Also, it has so many institutes within the EBI that participate in so many work streams that we almost cover the entire range of work that happens. And also Elixir Europe. All of these happen to be on the Genome campus near Cambridge, but that doesn't mean that the work only happens there. So there's collaborations with Cambridge University, which contribute. There's collaborations with industries such as Illumina, which also contribute. So it really is fairly pervasive in at least in the bioinformatics space around here, but also worldwide. Now, in order to work with the GA4GH, the first thing you have to find out is what it is that you're actually interested in. And there's a list of all the work streams. They are described in more detail, more than I can just say here. There's also roadmaps in what they're trying to achieve in the timeframes. And within each workstream roadmap, there's then a link to meeting minutes, which in those, there's a link to each of the subtasks. And that's where the actual work is taking place. So each subtask deals with one standard. Each of them has their own Zoom meeting that happens every month. Each of them has their own standards documentation, which is in a GitHub repository. Each standard has implementations. Hopefully we have links to them within the repos. But all of that is really open and public. So if you are curious about, let's say you want to use the CRAN file format, you would just go to that page, find the CRAN meeting, and just join it. The Zoom link, the Zoom details are there, and everyone is welcome and encouraged to support and join. In addition to that, we have other outreach. So there's plenty of workshops going on. Our primary outreach is an annual plenary conference, which happens in the autumn every year. And in the spring every year, we have a sort of a smaller leadership-oriented conference. And that is important because by now we have so many different work streams and so many different people working on standards. It is really hard to keep an overview. And so in those Connect meetings, we're trying to mix up those groups to make sure that each standard that is being developed actually is compatible with each other, which as we are growing and growing, gets harder. It is also important. One thing that is necessary for a standard to exist is there have to be implementations. So again, that goes back to what we are trying to standardize has to be usable. And part of the usability is that you can just go out, have an implementation, work with it immediately. So there have to be 2 reference implementations. However, what the GA4GH delivers and stands behind is just the standard itself, so not the software. What the product is in the end is a standards document, such as VCF 4.3. There's a PDF file that clearly outlines what the standard looks like. And that's what is certified by the GA4GH. If you write software that implements that standard, we would link to it. It would probably be used throughout the community. But saying that there is an implementation does not imply that the GA4GH has audited the code or any of that sort of thing. So it's always a difference to keep in mind. And that's particularly important when dealing with a security-oriented standard, such as like a cryptographic file format. You still have to take proper care about the code you're using. Not only that it fulfills the standards that are set out, but also that the implementation itself follows minimum requirements. So I thought maybe an interesting way to go through how the GA4GH works is to go through how a standard comes into being. The standard that I'm task chair of is a Crypt4GH, which is a file format that is encrypted, but it allows you to use the data in the same way as if it was unencrypted. So if you add it to your tool, you can read and write encrypted data, and it's only decrypted in main memory for the time it is being used. And I want to briefly go over how we came to proposing and then going through implementing that standard. So what is the path that is from a sort of, we think it's a good idea, to an actual standard. And as a quick background on how we came to the idea of starting this is just going back to the EGA. That is that's one of the sub-teams in the European Bioinformatics Institute. And the EGA is the European Genome Archive, which is one of the archives that keep human genetic data for research purposes. It's one of the largest in the world. It's counterpart to dbGaP in the US and DDBJ in Japan. And those three really capture the vast majority of human genetic data for research. So when I started working there 10 years ago, I think, one of the, well, next slide actually. So what we do is we accept data that has been used in papers for publications. Journals usually require you to make the data available, and journals often require that you have an EGA accession ID or a dbGaP accession ID to verify that the data will be publicly available once the paper is published. So you submit the data to the EGA. It does not become the ownership of EGA. You remain the owner of the data. That means in order to get access, you have to nominate a data access committee that will make decisions later on who the data will be shared with. And the EGA holds the data on your behalf, and it distributes the data on your behalf. That means as archive, it has the responsibility to keep the data safe, secure, and also make it available in an easy and quick way. One of the components of keeping the data safe is we keep it encrypted in our archive at all times. If you download it, it arrives on your computer in an encrypted format. Then it passes over into your responsibility. So once you download the data from the EGA, you're now responsible for keeping it safe, which takes very different shapes and forms. So we have had clients who would download the data, put it in an HPC environment, which doesn't have direct internet connectivity, then decrypt it and use it there. So that's super secure, can't really complain at all about that. On the other end of the spectrum, you have users, smaller users who download your data, download it to a laptop, decrypt it, use it, and then it lives on the laptop or it lives on a shared group drive. And we don't really know what happens there. We don't really know who has access. We don't really know what happens if your laptop gets stolen. And so those are the sort of two extremes of what happens once the data is accessed. And it's a bit frustrating to see because we have really no control over that as an archive. But it would be nice if we could extend the security of the data a little bit. So the question is, how can we encourage users to be a bit more secure with the data they receive from the archive? How can we extend the security of the data beyond the archive into the actual usage? One option, of course, is keep the data encrypted at all times if possible, and make this encryption transparent to the end user. Because in many cases, the users who download the data and run analyses are not technically versed, so they wouldn't be able to run the decryption or to have some complicated commands that allow you to access intermediates that allow you to access the data. So that's always sort of a bit of a tension between keeping it secure and easy to use. So that brings me back to when I started at the EGA. One of the first tasks I had was to actually think about a way of encrypting the data for the archive that allows us to index it and also decrypt only components of it. At the time when I started, everything was GPG encrypted. So if you wanted to access a little bit of it, you'd have to decrypt the whole thing. We wanted to be able to access only parts of the data so that we could work on them within the archive without having huge staging spaces of constantly encrypting and decrypting data. And I didn't actually have to do very much here because the AES standard already existed. If I use AES counter mode, I can encrypt and decrypt AES blocks at will. Plus the AES data is an XOR of the plain data. So any index files I had would already be valid on the encrypted data as well. So that gave me time to actually write tools to use AES data. So I wrote tools to encrypt it, to allow users to prepare submissions to the archive. I wrote tools to download the data. I wrote some microservices to use internally to access the data. All of that is still available in the EGA GitHub archive. It's all some Java code that I wrote a long time ago. The interesting idea here is that the download client, so I built in a client that allowed you to download data and to decrypt it. But I also packaged a Java-based fuse layer onto it. So you could download the data, leave it encrypted, start the fuse layer, and it would decrypt the data as you accessed it, and only the portions of data you accessed. So it would never write unencrypted data to disk, which I thought was a great idea. I also created a fork of the HDS JDK library that would allow you to open a BAM file or a CRAM file directly from the encrypted stage and use it. So here the decryption would happen as HDS JDK would read the data and so on. So these are all great tools, and they would be, so the idea is if users would actually use them, they could keep the data encrypted and still use it with their normal tools. And then it would actually be secure and safe, even if you store it on your laptop and lose it. However, the issue is here, all of these tools we had to write ourselves as EGA archive. It is understandably kind of impossible to go somewhere else and say, hey, I've come up with this way of dealing with data. Can you add it to your code? So the question here became, how can we take something that already works, but make it into something that might even be extended into the ecosystem, so that a tool developer might come and say, here's a new file format, I can add this to my code, and then it's a supported native part of my tool. That's when the idea started of creating a file format that would formalize all of these things in a way that the community accepts. So the first step in this project was to identify if this need that we saw is a real need. And so as we started to develop this product, that's how standards, the terminology of standards are used for in the GA48. The first thing we had to do was to create a product review committee. And the requirement was that it was comprised of people from various work streams to ensure that I'm not just getting my close friends and they say it's a great idea. So it has to be accepted as a good idea across many different work streams. So we ended up having someone from the Broad Institute, we had someone from EPFL in Switzerland, and then also within the EBI from the VCF file format standard, our product review committee. So they then have to listen to you explain what you're trying to do and actually agree that this is an idea that has usage for the entire community, not just for a very small niche and nobody would use it. So you work with them to develop a description of what it is that you're trying to set out to do. This will also have to have some initial reviews by the regulatory and ethics work stream, just to make sure that you're within any regulatory environments that might be affected. Ethics is part of the whole kind of work that we're doing with human genome data. A security work stream is quite important here. They were actually our strongest critics in the beginning, simply saying, have you looked at this one? Have you looked at homomorphic encryption? Have you looked at secure third-party computing? Have you considered this? So they were very, very strict in having us do our preparation properly, which was actually pretty good. And then one of the things you also have to prepare to do outreach and partner engagement later on, again, so that the standard actually gets being promoted throughout the community, being used. There must also be 2 maintainers who write implementations. and maintain the standard throughout its lifetime. So then you write a proposal once everything has been signed off by the various committees and send it to the steering committee. The steering committee is literally a cross-section of academia and industry. That's the leadership across all the different work streams. They look at the documentation and vote on it. So they also have to agree that this is something worthwhile pursuing. And if this is accepted, you then get some administrative support. So you'll start having a Zoom meeting room, start having regular meetings, and etc. So this is where the actual work takes place. Once the steering committee voted to give you that as a developing standard, you then try to get people interested in the topic and capable of contributing, come together. You have regular meetings, you develop a standard, you develop implementations. It's sort of an iterative process until you're sort of happy with what you have. You have some code, you show it works, you have a document that lists out what the standard should look like, and you have all the documentation. You then go back to the original people who you had at the beginning of this journey. Security, again, in this case, that was very important. They did a very, very close and thorough review of the standard. We had actually picked one of our product review committee members from the security work stream, so they had a good idea throughout the process of what we're doing, which made this a bit easier. But once they were happy, regulatory and ethics was not a huge deal for a file format. That's more important in, for example, data discovery and things like that. Once you're past that and you think you're ready, your product review committee has to review it again. They comment on it, they have experiences with the own standards they support, etc. And there's also an open review where the public can go and comment, criticize, whatever on the standard. So again, you go back, you address those, and that's an iterative process. Eventually you go back to the steering committee, you do a presentation, they have seen all the documentation, and again, they vote yes or no. And if they vote yes, it is approved as a standard. You then have standard version 1.0, and you're going towards trying to outreach, encourage adoption, usage, etc. A quick word on the numbering scheme that is being used. So you start out with 1.0, and it's pretty standard. So minor fixes would get you to 1.0.1. A major but compatible update would get you from 1.0 to 1.1. If there are too many changes, which would mean the next version of your standard is incompatible, it breaks the compatibility, then you would go from version 1 to version 2. But version 1 to version 2 is treated as a whole new standard. So you have to go through the whole process again and explain and convince people that this is actually a worthwhile enterprise. Why break something that people are already using, etc. In my case, Script4gh, so we have a lot of implementations out there. There's Python, Rust, there's a Java 13 implementation. There is HTSLib or C-based implementation available that allows you to build SAM tools that can read and write Script4gh directly. There's a Java 11 version. There's a Fuse layer. There's some proof of concept HTS-JDK support, and I'm supposed to be working on Picard and GATK as well. Yes, I have time. There are challenges, but in note of time, I just want to go here. If you're curious about what this file format is capable of doing, how it is being used at the moment, you can just Google for Script4gh. There's a presentation we gave at last year's plenary. There's a poster, and there's also now a paper in Bioinformatics Application Note that introduces the standard to the community. And yeah, that's really it. In summary, I just want to say that G4gh really tries to cover all aspects of genomics, but not by burying everything in standards, but to keep the number of standards at a minimum and make every one of them as useful as possible. We're not trying to create anything that's not necessary. It's an open organization. Everything is open. Meeting notes are open. Meetings are open. So if you are interested, I encourage you very much to join, to contribute. And code contributions are welcome at all times as well. Thank you.
Thank you very much, Alexander. That was a wonderful and very encompassing talk. So I'd like to remind people to ask questions in the Q&A box if you have any, or via the chat, and we'll address them as we go along. And maybe to give people a bit of time to compose their thoughts, I had a couple of questions that I wanted to quickly follow up on. So you already mentioned the crypt4gh reference implementations, and you said, okay, there have to be multiple driver projects to show that there's adoption, and they have to be quite diverse. So do you find it difficult to drive adoption in the wider community, or to find sort of outside projects that are willing to implement the reference standard, or do you have like some ideas around that?
It's a mixed bag, I must say. So generally speaking, when we present this at conferences, people like it. They like the idea of it. But then you have, on the one hand, the large organizations that say, oh, we are ISO 27001, we have triple firewalls, you have all our hard drives are encrypted. We don't really have a need for it. So we have those people who have thought about security in the past decade already. And then we have smaller projects which don't really have the manpower to contribute, who say, this is exactly what we need, when can we use it? So finding people who are both interested and have the bandwidth to contribute code-wise is not easy. We're lucky enough that there's at least 3 or 4 places now who are contributing to the code, but there could always be more. So for example, I don't think there's a demo yet for a Python-based PySam implementation that uses crypt4gh directly, something like that.
And then I actually had a follow-up question about that, and I think you went in that direction quite well, but you mentioned explicitly GA4GH does not pass judgment about how valid or preferred these implementations are. But have there been any talks of adopting some of the implementations as the standard, and maybe auditing the codes or even doing some formal verification to say like, hey, this is really tried and tested and you should use this?
So there's discussions about that, but generally speaking, we don't want to get into that because it is just something that doesn't scale. What we do say is we have, so for example, we have 2 reference implementations that we created along with the standard itself. So we say those are something we would use. If you implement it, it's great, but we can't go into more details. So there's discussions on sort of having endorsements, but those are still at the beginning. In recent months, there have also been some programmers that have been hired to the GA4GH organization. So that gives us a bit more scope to actually go in that direction. But it's a slow process.
Yeah, thank you. In the meantime, I see there's a couple of questions in the chat box. So for some reason, the Q&A box has stopped working or something, but I'll read out the questions. So Leandro asks, is there a centralized mechanism to validate that a given implementation of the format complies to a minimum set of requirements defined by the format? So maybe go in the same direction and sort of overlapping with my question.
So there is not, but it varies depending on standard. So the cloud workstream, for example, it's working on a framework to do precisely that. So they have a set of standards to run workflows, and they're creating a framework where you can plug in an implementation and see if it produces the outcomes expected. Some standards have test data with known results, so you can use that to show that your implementation complies. And some have nothing. So it really varies depending on the individual task that is involved here. There's nothing centralized though.
Okay, and a question from Ole. Alex, what is your take on the discussions around the MPEG-G format?
That's actually an interesting topic because that's a direct competitor to CRAM. And in the beginning, the CRAM maintainer was contributing to MPEG-G until he realized that what they were doing is just trying to register patterns left and right. And so he went out and showed that nearly all of them were actually prior art and they were already implemented in CRAM. So the relationship between the two has sort of soured a bit. I don't think necessarily it's a bad idea to have two standards, but if you have the choice of an open standard that is supported by the community and one where you have to pay for usage, I think my preference would be to have it open for everyone to use out of the box.
Thank you. In the meantime, I don't see any further questions coming up, so I think that might be it. So with that in mind, thank you very much again, Alexander, for the talk, as well as Vincent for the first talk. And with that, I think we are at the end of our discussion. So thank you again very much for coming. Thanks to our speakers for giving wonderful talks, and we hope to see you for next month's meetup as well. And I hope you have a good remainder of your evening, and goodbye. See you next time.
Bye-bye, everyone.
Thank you. Bye.